So we are talking about limits to infinity. Either positive infinity or negative infinity. And this is what I call type 3 limits. Okay, so let me reiterate this again. We only do what we are about to do if the limits are going to positive infinity or negative infinity. Okay, if it's the limit as x goes to a point like 2 or -1, then we do what we have seen previously, right? We check to see if it will factor, we simplify, then we plug in, or we might just plug it in. That is if it's going to a point. Okay, if it is going to positive or negative infinity, then we do this. Okay, so there are 3 different categories or groups here. Okay, first one, if the highest power is in the denominator, then the value of the limit is going to be, remember from pre-cal, have a little acronym, BOBO, right? Bigger on bottom, the value of the limit is 0. Okay, so look up here. We have the limit as x goes to plus or minus infinity of 3 over x squared. The degree of the denominator is 2. The degree of the numerator is 0. Therefore, it's bigger on the bottom. Therefore, the value of this limit is 0. Okay, let me, in case conceptually you have not or do not understand why, let me show you why it's going to 0. Okay, so let's plug in some values as we go to infinity. So I've got 3, that's constant. Let me plug in 3. 3 squared would be 9. And then I've got 3 on the top. Let me plug in 5. That would give me 25. And then let me plug in 10. That would give me 3 over 100. And then let me plug in 10,000. Right? That's going to give me 3 over 10,000 squared. What's that, 1,000,000? Am I doing my math right? Somebody help me, okay? Okay, what's happening here? What are the numbers doing? They're getting smaller and smaller and smaller, right? Because my denominator is getting larger and larger. Therefore, I'm dividing by a larger number. Therefore, it is going to 0. Does that make sense? Okay, and we can see this graphically also. Here's the graph. All right, look up here. As we follow this, this goes way, way out there, and it's approaching the x-axis. Therefore, it's getting closer and closer to 0. Same thing on the negative side. Okay, so same thing right here. I've got the limit as x goes to plus or minus infinity. 5x over x squared plus 7. So the degree of the numerator is 1. The degree of the denominator is 2. It's bigger on the bottom, therefore it is going to 0. And you can also see that graphically, right? As we go way out to infinity, it's approaching the x-axis in both directions. Okay, all good? That's the first type. Okay, the second type is the highest power is the same. If it's the same in the numerator and the denominator, then my little mnemonic device, what is it? We remember from pre-cal. Okay. What does Betsy stand for? Bottom equals top, C, the coefficient. Okay, let me write that down. Bottom equals top, then it is the value of the coefficients. So the limit as x goes to plus or minus infinity, I've got 3x over 4x plus 1. I'm looking at the degree of the numerator is 1. Degree of the denominator is also 1. They're both equal. Therefore, the value of this is the value of the coefficients. So it would be 3/4. Well, what about the constant there? That doesn't matter. Why does it not matter? Well, think about it like this. Are we in this classroom on the second floor closer to the sun than people on the first floor? I mean, I guess maybe, right? But does it really matter? No. Okay, so if I spit in the ocean, does that change the volume of the ocean? The volume of water in the ocean, if you spit in it. I guess technically maybe. But does it really matter? No, it doesn't. Okay, well, so when we're talking about the going to positive or negative infinity, okay, infinity is a concept here. All right, the constant doesn't matter. All that matters is the coefficients of the leading degree term there. Okay, and so this one, same thing, 5x on the top, 3x on the bottom. Just be careful here, right? Careful, because I have a negative, so the value of this would be negative 5/3. All right. And that brings us to the last one. If the highest power is on the top. So I have a different acronym because I want to tie this to something that we do here in just a minute. All right. I call this BOT-NOHA. BOT-NOHA, which stands for bigger on the top, no horizontal asymptote. If it's bigger on the top, then there is no horizontal asymptote. That also means there's only two answers. Okay, it is either infinity, positive infinity, or negative infinity. Those are the only two answers if it's bigger on the top. All right, and here's why. Again, okay, so look up here. I've got 5x squared plus 1 over x. Okay, the degree is larger in the numerator, therefore it's going to be infinity or negative infinity. Which one? Well, it depends on what we're plugging in. In this case, we're plugging in positive numbers. Yes, so I plug in positive numbers, it's squared. So that makes it positive on the top. And then if I plug in positive numbers on the bottom, it's also positive. Therefore, the value of this has to be positive infinity. And again, it's getting much larger in the numerator than the denominator. Like if I plug in 1, I get 5 plus 1, which would be 6 over 1. But then if I plug in 10, I would get 501 over 10, right? And so it's increasing faster in the numerator, therefore it's getting much larger. Therefore, it's going to either positive or negative infinity. And you can see that on the graph, right? If we're out going up this way, this is increasing to positive infinity in the positive direction. But if we look at this and we're going in the negative direction, I'm plugging in negative numbers. So if I plug in a negative number and square it, it becomes positive. But if I plug in a negative number in the bottom, it's going to be negative. So I have a positive divided by a negative, which gives me negative infinity. And you can see that on the graph. Okay, look up here. So we go out, out, out. That's going down, 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 all the way down to negative infinity. There. And the point that I want to make now, all right, and I will come back to, is that it does not have a horizontal asymptote, whereas the others do. Okay, so look. Right here, this has a horizontal asymptote right in there. You see that graphically? What's the value of the horizontal asymptote? Say that louder, Jimmy. It's 3/4, right? Well, what's the value of the horizontal asymptote here? 0. Okay, and the value of the limit is 0. Well, if it's going to positive or negative infinity, then there is no horizontal asymptote. Okay, because this graph is going up, this graph is going down, and it's not approaching any horizontal line as it goes way, way out there. Okay, so take a second and do these for me. Will you do that right now? Okay, so here, both of these are bigger on the top. Yes, therefore the answer has to be either positive infinity or negative infinity. Which one? Well, we are plugging in positive numbers on this one because it's the limit as x goes to positive infinity. So if I'm plugging in positive numbers, it's squared, which makes it positive, but then it's multiplied by a negative, which makes it negative. And I'm plugging in positive numbers on the bottom. So I've got negative divided by a positive, that is negative infinity. Yes.
So you're not looking at all at like the plus 3 is the.
That doesn't matter at all because of what we were talking about earlier. All that matters is the leading term there of the term of the highest degree. Okay, on this one, I'm plugging in negative numbers. So it's squared, which makes it positive, but then it's multiplied by negative, that makes it negative, and I'm plugging in negative numbers to the bottom. That makes that negative. Negative divided by negative means it is going to positive infinity. Okay. Any questions for me on that? Well, why don't you turn the page? And there's 3 quick little problems there. Will you do those for me? So check with your neighbor. All right, help them out if they got stuck.
I don't want to go to
All right, here we go. limit as x goes to infinity of 3x plus 8 over 4 minus 7x. Degree of 1 in the numerator, degree of 1 in the denominator, both of them the same as the value of the coefficients. Therefore, this would be 3 over negative 7. Okay, watch the negative there. Limit as x goes to negative infinity. This one is bigger on the bottom, therefore the value is 0. This one, the degree of 4 in the numerator makes it bigger on the top. So it's either infinity or negative infinity. If it's raised to the 4th power and I'm plugging in negative numbers, that will make it positive. Because it's a negative number raised to the 4th power. And then the bottom is going to be negative because it's a negative number raised to the 3rd power. That makes it negative infinity. Yes.
Do you want me to put leading coefficient or like the first two?
Yes, that's all that matters. Doesn't matter at all. Okay, all that matters is that and that. Okay. Okay, again, we only do this. We only use the acronyms, Bobo, Betsy, Bot, Noha, if it's the limit as it goes to infinity or negative infinity. If it's going to a point, then we're going to check to see if it will factor. All right. Simplify and plug it. All right, here we go. Vertical asymptotes. To find vertical asymptotes, we are going to set the denominator equal to 0 and then solve. But only the non-removable discontinuities. Okay, so look, this says find the vertical asymptotes of the function. I have x minus 4 over x squared minus 3x minus 4. So let me factor the denominator. That's going to give me x minus 4, x plus 1. Two x minus 4s cancel. Right, meaning there's what? Okay, there's a removable discontinuity there, or there's a hole in the graph. So if it's a removable discontinuity, then there's not a vertical asymptote there, right? So I'm going to discard that for a second. And then I'm going to take x plus 1, what's left in the denominator, set it equal to 0. And solve. That's going to give me x is equal to -1. Therefore, I have a vertical asymptote at x is equal to -1. So in other words, we have a vertical asymptote whenever a value makes the denominator undefined. Assuming that there is not a removable discontinuity. And you can see it in the graph here, right? At -1, we've got a vertical asymptote there. Okay, so let's look at this one. We have g of x is equal to 2x plus 6 over x squared minus 9. So I am going to factor a 2 out of the numerator. That gives me x plus 3. And then I'm going to factor this to x plus 3, x minus 3, and then my x plus 3's cancel. Therefore, I have a vertical asymptote at x equals 3, because if I take 3 and plug it in, it will make the denominator undefined. And I have a vertical asymptote there. Okay, well, that leads us to this. That's vertical asymptotes here, and this is why we have the acronym HA, okay? To find horizontal asymptotes, find the limit as x goes to positive or negative infinity. Okay, so look at this. It says, find the horizontal asymptote for f of x is equal to x minus 4 over 3x minus 4. So the limit as it goes to infinity, I'm going to look at the values. I've got a degree of 1 in the numerator, a degree of 1 in the denominator, so it's the value of the coefficients. And so a lot of times students will write 1/3. And it says find the horizontal asymptote, and the answer is 1/3, but that is not technically right. Why not? Well, a horizontal asymptote is it's a line, right? Is this a line? No, this is just a number, right? So, gotta do that. Y is equal to 1/3 is the horizontal asymptote. Do I know what you mean? Of course. Will I still count it wrong? Of course. Right? It's not right mathematically. We gotta have the y is equal to 1/3. So what if it is a vertical asymptote? How would I write that? It would be x equals. And then whatever the number is there. Okay, so turn the page there. And why don't you try A, B, and C there? Okay, it says find the horizontal asymptotes. So do that for me, please.
Oh, I see. Yeah. Okay.
Okay, so let's come back. It says find the horizontal asymptotes. F of x is equal to x plus 1 over 3x plus 2. I want to find the limit. And this goes to infinity. The degrees in the numerator and the denominator are the same. Therefore, I'm going to look at the value of the coefficients. Therefore, my horizontal asymptote would be y equals 1/3. This one, it is bigger on top, so they're bigger on top, no horizontal asymptote. So no horizontal asymptote. There is a vertical asymptote, right? At x equals -1, there's another type of asymptote. There's a pause, pre-cal. There's a slant asymptote, but we don't need to worry about that. Slant asymptote. But we do not have to find. Okay, and so part C says if the horizontal asymptote is y is equal to 4, find the value of a for which f of x equals 8x squared minus 3 over ax squared. Okay, well, this is saying it has a horizontal asymptote, and the horizontal asymptote, the value of that has to be 4, which means the limit as x goes to infinity of my function, sorry, infinity, let me erase that. The limit as x goes to infinity of my function, the value of that is 4. Well, I've got a degree of 2 in the numerator, a degree of 2 in the denominator. They're the same, so I'm looking at the value of the coefficients. So I know that 8 divided by something is equal to 4. Therefore, a equals 2. Yes.
Question, do we have to show like word, like?
As a general rule, yes. Okay. Bald is bad. Bald answers get no credit on the AP exam. Okay. However, okay, this type of question is probably like a multiple choice question. All right. And so multiple choice questions, obviously you don't have to show your work. All right. So normally kind of the way that I go about that is if you can look at it and know the answer, and there are certain types of question where that is applicable. If you can do that, then no, you don't have to show your work. That said, however, if I cannot look at it and know the answer, then neither can you. So show your work. Okay. And you will see this as we go on in the course. Okay. We care more about how you get the answer, the process of getting the answer, sometimes than the answer itself. Okay, the answer itself is important, but it's not the only thing. Okay, and so when we start working on free response questions and looking at the different parts, you may see that a certain section is worth 4 points. This step is worth 1 point, this step is worth 1 point, this step is worth 1 point, and then the final answer is worth 1 point. So if you just write it down, the answer, what you did in your calculator, for example, and write down the final answer, they're going to mark it wrong and move on, and you get nothing. That makes sense? Did I answer your question? Okay. I tell you what, here we go. Example 3 says, find the one-sided limits without a calculator. Okay, so put those calculators away. We are going to head into the calculus jungle, right? Where all we have is our calculus wits about us. So here we go. This says find the limit as x goes to 1 from the negative side. It's a one-sided limit of x squared minus 3x over x minus 1. So first thing I want to make a note of, if we are going to 1, what is there at 1? There's a what? There is a vertical asymptote at 1. Correct? So I want you, let me scroll back here. Let me make a note of that. Vertical asymptote at x equals 1. So let's go back and look. Let's look at this function right here. There is a vertical asymptote at 1. Correct? So the value of the limit has to be what? It either has to be positive infinity or it has to be negative infinity. Those are the only two possible answers if there's a vertical asymptote there. Does that make sense? Okay, so the value of this is either positive infinity or negative infinity. Well, how do you decide which one it is? So this is how, okay? Number one, pick a test point close to the asymptote on the correct side. And I'll explain what I mean by that in just a second. Pick a test point close to the asymptote on the correct side. And then number two, check the sign. If the sign of that test point is positive sign, then it's going to positive infinity. Negative sign, and it's going to negative infinity. Okay, so let's kind of work through that. This is the limit as x goes to 1 from the negative side. So I'm going to pick a test point on the left side of 1. Let's say, let me come down here, test point is 1/2. Okay, why did I pick 1/2? Well, it's close to 1. And numerically, it's on the left side of 1. Does that make sense? Okay, so now I'm going to take 1/2 and plug it into the function and see whether I get a positive value or a negative value. Okay, so let's do that. If I plug in 1/2 minus 1 in the denominator, I get a negative value. Does that make sense? And then if I put 1/2 into the numerator, I'm going to get 1/2 squared, which is 1/4. And then I've got -3 times 1/2, which is -1.5. So I've got 1/4 minus 1.5, and that is a negative value. So I've got a negative divided by a negative. Therefore, this is going to positive infinity. Okay, good question. Why did I pick 1/2? You want to pick a test point that's close to the asymptote. So it's got to be a value close to 1. And then it's got to be either on the left side or the right side. Okay, in this case, it's approaching from the left side because it's negative. And so 1/2 is on the left side of 1, numerically. 0, 1/2, 1. Okay, here it's the limit as x goes to 1 from the positive side. So my test points, I'm going to pick test point. Let me do a test point of 1.5, 1.5, because that is on the right side of 1. That makes sense? So now I'm going to plug in 1.5. Okay. So I got 3/2. 3/2 squared is going to give me 9/4 minus 9/2. Then I plug in 1.5 to the bottom. Okay. So I've got 1.5 minus 1. So this is going to be positive Yes? And then this gives me 9/4 minus 4.5, which is negative. Therefore, this is going to negative infinity. That makes sense? Let me do one more quickly here. Okay. On this one, it's the limit as x goes to 2 from the negative side. Well, there's an asymptote, vertical asymptote at x equals 2. Because if I plug in 2, I get a 0 in my denominator. However, what do you notice about the denominator? It's squared, therefore it has to be positive because it's squared. So this is always going to be positive. And what about the numerator? It's always -1, therefore this is always negative. I've got negative divided by a positive. So therefore the value of this is negative infinity. Okay, almost done. Hang with me. Here's what I want you to do. I want you to do the next 4 problems in your notes there. They're fairly quick. And then I'm going to give you a test problem to end our day and see if you can get it. Okay, second period, it took them a little bit, but someone finally got it. All right, so there we go. Do the first 4 and then I will give you the test problem. Go. Okay, here we go. Tell me the value of the limit, please. Again, what'd you get? Okay. And the horizontal asymptote. What'd you forget? Up or out? There we go. Equals 4. There we go. Everybody okay? Number 2. What is it? 0, bigger on the bottom. Horizontal asymptote. Y equals 0. All right. Number 3, the value of the limit is negative infinity. Horizontal asymptote. No horizontal asymptote, but no ha. Okay, then we got a multiple choice. For x greater than or equal to 0, the horizontal line y is equal to 2 is an asymptote for the graph of the function f. Which of the statements below must be true? Okay, so they tell us that it has a horizontal asymptote. Correct? There is a horizontal asymptote at y is equal to 2. Therefore, what must be true? The value of the limit as x goes to infinity of the function is 2. It has to be e. Why? Well, because the value of the limit as it goes to infinity is the value of the horizontal asymptote. Therefore, there's a horizontal asymptote at y is equal to 2 if the limit has a value of 2. All right, you ready? Here we go. Here's your little challenge problem. Tell me the value of this limit. I want the limit as x goes to infinity of e to the negative x. So the numerator is constant at 1, right? And then the denominator is increasing, right? If I plug in 0 for x, I get 1. If I plug in 1 for x, I get e, which is like 2 point whatever. If I plug in 1,000, I get e raised to 1,000. So what's happening to the denominator? It's getting larger and larger and larger, therefore the value of this limit is 0.
Which one's your vote?